你要选哪个？这个就很好，就是这样的。这个就不用太。
Oh, are you ready? Are you still sending the messages? You can finish it first. All right. Okay, now one more step. Based on the previous part, I'll just show you one more step I can do here. I'll just open it again. As far as I remember, okay. So I enlarge the screen again. Just we want to talk about how to. So I cannot open it. Can I open it here? Let me see. No. Because now you can see that in this page, I have not opened the options to use the toolbar. Right? That's why you can see that I can do almost nothing to create new things. But I can now change the setting again. So go to Edit Activity. Just to let you know how I can make adjustment. All right? So I can. So remember this upper part, you can do the editing of the applet, including the options of using the toolbar, input bar, right, menu, something like that. Okay, so you can make the choice. So I just quickly go back and save the close. So then, in such case, whenever I open this file again, then I can continue to do other constructions. Right? In fact, I just want to add a little bit. Right? I just want to make one more step to calculate the length here, because this is most critical, right? How this segment can be calculated based on the function. You can see the function f is defined here. Right? So I can turn it to. So how to calculate this one? What's the y coordinate? I define A, so I'll let you know again. A is the point h, f of h. Right? So everything is depending on f, the function, and the value h. Right? So B is just 3 units away. 3 units away from h. Right? So I can do it as, that means the point C is located between A and B, midway between it, right? So it is h plus 3/2. Right? This is the y coordinate of C, f of h plus 3/2. Minus, this is the coordinate of B, right? Which is the f of, sorry, I made a mistake here. This part, f of h plus 3/2 is the y coordinate of D, right? Y coordinate of C is simply the average of the coordinates, right?
It's 2h plus 3/2.
Yeah, so maybe I just.
No, it's the x coordinate.
The average of the y coordinates.
Yeah.
Yeah. Or I can use the toolbar here actually. I can use the fraction, I think. Let me show you. Is there a fraction option? Oh no, there's no fraction option. Okay, never mind. Then I just use the usual one. Okay. Just divide it by 2. Can you see this? So that is, this one is the y coordinate of C, which is the average of the y coordinates of A and B. Okay? And I use it to subtract y coordinates of D. The y coordinates of D will be f of h plus 3/2. Okay? And that is 2.25. So I just let you know, I can do the calculation in this way. All right? Based on what I know about f or the point h, right, which is the movable value, the changeable value here. And of course, what's interesting is that now we go back to the graph to confirm this value does not change. I mean this value, right, does not change with h. You see that? Right? So you can use different way to illustrate or to talk about this relation. So this applies to any quadratic, I believe. All right? So let's see. I just change a little bit. Okay, so this is another quadratic. Okay. And then of course the value, how about the value? But interestingly, do you notice what happened? I changed to another quadratic function f, but this value is not changed, still not changed. Do you notice that? So it's also interesting. Right? So what does it depend? Now okay, if you like to play with this further, then I can just add another, maybe I can add another point. Okay, so I now take it as h plus 3. All right? The point P is 3 units away. I can make it any units away from h. All right? So I make any other value I can use. Maybe I take n equals 3. Okay? And then I just modify correspondingly the point B can be h plus n and f of h plus n. Okay? And then the next thing I can change will be this value. You see that? So now I modify it, right? So B is now n units away from the point A, which I can also modify if I like. Okay, I like make it 4 units. Can you see this? And then I move h again. And this value is 4. It's also just 4. Okay? So even when I change the function, perhaps if I change it to 4x minus 1, it's still 4. I think I can turn off the tracing now. Sorry? I traced triangle instead. I'll just undo it. So it may be easier to see. Okay, so can you see that? Oh, sorry. It's still triangle. It's a bit annoying. All right, never mind. Okay, so I leave you to consider to investigate. All right. So which factors or which number affects the value? Right? Affect the length of every area of triangle. All right. To what extent I can change the function without changing this value? Perhaps you can also pass. Right? Find about it. So what is the relating? Which part that is affecting the elements or the areas, and so on. And by the way, meanwhile, I can show you all this symbolic calculation, a little bit more symbolic input, but not entirely symbolic calculation actually, right? But I just let you know I can make use of this function values or the symbols to represent the expressions, and also shows the relevant value. So part of the mathematical work can be done directly through the input here, right, in the software. But of course, it's still detailed algebraic work needs to be left to the student to do it with the pencil and paper. Okay, maybe that's all for this part, perhaps. So let's see, and maybe I quickly show you something in geometry. Is it okay? So you can also play a little bit with the geometry here. So you already see me demonstrating some basic construction in geometry, actually, right? So just show you a little bit more, right? And so you can see long list. Perhaps I already demonstrate quite a lot. Now I like to do something with transformation. Perhaps I haven't tried anything with transformation yet, right? So I can do something with the transformation, and even with vectors, right? This will also be covered in the IB curriculum as well. I show quickly my files here to give you some starting point. Here is my file. If you go back to my workshop samples, I think in the sections of pattern, you can see some different kind of geometric constructions. And this one can be quite interesting to study. Do you know this specific tessellation? Do you know? Have you come across this? Right? Now, you can see some pentagon, right?
Yeah.
Right? My question is that, what's so special about this pentagon? I should be able to move it. But let me check also.
Does this have something to do with our McDonald's example?
Hmm?
Does it have something to do with the McDonald's example? We had it 2 weeks ago. The McDonald's
Oh,
stores.
I see. Not particularly.
Okay.
Not particularly. I have a problem with my files here. It's not interactive. Okay, so now it works now. So I can still change it in some way, but it still remains tessellating.
So every single piece on this map should be the same.
So the same, congruent, the same pentagon.
Yeah,
Right? So now, it's also interesting for you to try to describe what's so special about this pentagon. Do you see any special properties? How will you describe this pentagon? It is not regular, right?
Yeah.
But anything interesting about this pentagon that you can recognize?
The area doesn't change.
Area, that means maybe. But just because I fixed some points,
Yeah.
if you can now because I just concentrate on moving this point, right? But if I remember this point can be moved,
It's like a bag of liquid.
right? So it's not directly related to area, because areas is not. Areas is not particularly relevant in discussing a tessellation. Am I right? In discussing a tessellation, area is not directly related, right? Perhaps.
So the 2 points are fixed, and then the other 2.
Well, I just have 3-point movable,
Yeah.
right? But anyway, the point is that no matter how I move it, what is being constant in the previous shape? What properties remain the same? Can you quickly see? Any idea?
Central?
Hmm?
The central of the
Just because I fix it in a particular way.
Okay.
Yeah. It's also not relevant because you can translate it.
Yeah.
So that's why the center, where it's center, is not a particular crucial or critical part. Okay?
The perimeter doesn't change?
No? Huh? No, you like to continue to move it?
The 2 lengths are the same.
2 lengths. Which 2 lengths? Can you
This
come up the point up?
this.
Oh yeah. So two pairs of equal size, right? This pair, this is a pair of equal size. This is another pair of equal size, equal length, right? But nothing to do with this one. This length can change, right? I mean, can be different from these two pairs, right? But this is one pair, this is another pair. What else do you notice? How about the angles?
90.
How many 90 degrees angles do you see? How many right angles do you see within one pentagon? Two. This is a right angle. This is another right angle. That's enough. Right? This is what required in order to make this pentagon tessellating. All right? So you can try it. Okay? So actually, there's different types of pentagon that can be used for tessellations. Right? That can also be an area that you can investigate. Right? Because many people know that pentagon in general, right, regular pentagon. Of course, we know regular pentagon cannot tessellate. Right? But apart from regular pentagon, there are other special pentagons. There are actually many different types of special pentagons, right, that can tessellate. Right? So that is one type. And this also, you remember, I want to draw a pentagon with two pairs. Right? Now remember, these two pairs of equal size, which makes also a right angle in between. That's enough, right, to make such a pentagon. How can we draw it? So now I go to the geometry window, and you can try it. Now this requires a number of constructions in geometry, right, to complete it. Okay? So I start with one side. It's up to you whether you want to follow me, right? Because I may do it quickly anyway. Right? So I want one side, the base here, independent, okay, and another point above, right? Sorry, this should be just a point. So I just add a point here. Okay. And then I need a pair of equal size, making a right angle, another pair of equal size, making a right angle. Okay. So that is basically what I need. You can do it in different ways. Okay. So one particular way would be just okay. I can use a semicircle, okay, and then a perpendicular bisector. Here, the perpendicular bisector. Okay. So A, C, in order to create this point. Can you follow me?
Yeah.
Does it make sense?
Yes.
Okay. So a circle here, the midpoint, so you have a perpendicular bisector. If you join it, then you will have a right angle and two side equals. Okay? So this is the way we do it. Quite a number of different geometric constructions. Alright? And then now, later on, maybe you don't want to show it, then you can go back to this and then hide it. And also this one, you can also hide it. By the way, I should also go back to this setting again. I think it should be right. Oh yeah, keep it new points anyway. All right, so I quickly do the same on the other side. From C to B, and then another perpendicular bisector, and then at a point here. Now, remember, I hide this construction lines, but I do not delete them, right? Because all construction lines are interrelated. If you delete them, then the dependent objects will also be cancelled, right, or removed. Right? But now you can see just the pentagon. Do you notice that? Okay? Remain the same. So the next thing is how to make a pentagon that can tessellate. I mean, use it to tessellate, right? Now I go on to add a polygon here. I can fill it with a pentagon, and then later on use this pentagon by transformation. Right? So I can use do different transformation based on this to fill up the space. Right? So that is now. So now we have some lines. These are hidden. Only these are hidden. Pentagon, one pentagon. Right? Points, the number of points. Right? And together, the segments are not very important. So I close it. So go back to this one. Think about it. How to tessellate. So what's the next step? How can I turn around it? What should I do in order to turn around and move around so that it can tessellate?
Link 2 points upon the.
So I have one now. Okay. So what kind of transformation should I do?
Fix 2 points.
If you think about it first, right? Let me update the messages. So, any suggestion?
Like a spin.
Hmm?
Like a spin.
Spinning. Okay, I can do rotation.
Oh,
I can do the rotation. Yeah. But which part can I rotate? I think, can you see this part?
yes.
If I rotate, and then, or maybe this side. So you can do it by rotation. Or you can rotate, you can do 4 copies. You can rotate 4 times, and then translate to the other part. Right? Or I can create a hexagon. This may be more tricky. Can you see the hexagons? So you can fill up by groups of hexagons as well. Right? But for making the groups of hexagons, then you need not just rotation. For example, this group, you have to, you can also do rotation. No reflection actually, it's 180 degree rotation. I can do both, right, to show you how it works. But there can be more than one way, all right, anyway, right? There can be more than one way. All right, now, let's try to rotate about the midpoint of AB. Okay, so I have a polygon, and then I can now rotate it around points. Okay, so I can rotate this here, rotate it around the point F by 180 degrees. Can you see it?
Yes.
Or I can let me see, reflect. Another term, in this case, in this special case, right, well, since you reflect by 180 degrees, you can also say that you reflect about a point. Okay? But it's a special term. Anyway, you can try it. Reflect about a point F. Then you will get the same effect. Okay? It's special. And then on the 2 sides, I have to rotate it by 90 degrees. Okay? So I have to rotate this one 90 degrees through the point D. So let's try it. Rotate this one about the point D by 90 degrees. Clockwise or anti-clockwise? I think it's clockwise. Actually, it's I do the same on this side about the point E. Do you see I click it, right? I click the object and then the point. This time I do anti-clockwise. Okay, so I have 4. Right? So a lot of things created. I have to hide it. Right? So I have 4 polygons. Right? Can you see this? Okay. Now the rest have to be done in a better way. I cannot, because if you continue to move bit by bit, one by one, you need a lot of time. Okay. But I can do it all together as one piece. But I have to rename it first. For this one, this is polygon 1. Okay. The other one, just to make it easy to type. Okay. So we can try to rename it as polygon 2, 3, 4. Okay. It doesn't matter, it's just a name, okay, to make it easy to type. And then I group them together. So I create a new name, make a tile, put it together as one big tile, okay? So it is a set. Then use the set symbol. Poly 1, poly 2, I put it into one set, and then it will be, it can be controlled or manipulated as one object, right? So I say poly 1. Poly 2, poly 3, poly 4, so forget about the numbers, right? It doesn't matter. Actually, what's important is that these are now put together under one object, and you call it a tile. And then with the tile, I can further move around the whole big tiles any way I like. Okay? Actually, the rest is just translation. Right? So I can use the vectors. But what should be the vector? Now, maybe I start with some experimentation first. Okay? I can just make a free vector. So maybe this one. Right? Just to explore a little bit. Okay? So this is one vector. Okay? And this vector is called the vector U, divided by the GH. GH are the 3 points. Okay? But based on the vector, I can move around the whole object tile. Okay? So I can translate. So I type inside here. So translate is a command. Right? I translate the tile by U. Okay? So it may not work until I adjust it. You see this? Okay? So if it fits, then I can continue. Now I can translate. In this case, you can now practice some work with vectors. Okay. Negative U. They will go to this side. Okay. If the 2U, then it will go further out. You can see this? So it's like playing with the vectors. Okay. Or something like that. But it's not enough. Just go in this direction is not enough. Right? You also have to go into another direction. Right? So what could be the another direction? Maybe I just create another vector to try a little bit. Let's see, I just put randomly on here. I can adjust it later on. Okay. So another one will be, now, translate the tile by the vector V. Another vector is V. Okay. So I can move it like this. Now it works. Okay. You see that? Okay. Now you can continue with the calculations of vectors. The same objects, U plus V. And so you can think about it, what will be the others? This one is U plus V. Right? So actually, at the same time, I'm working with the vectors. In fact, right? So think about it, these are the two vectors I already set. But in fact, these vectors if you put it back to the files, you find that they are just this one and this one. You see it now? Okay. So I can define from the beginning these vectors, right, in order to make the translation. So let's try to redefine it, perhaps. So what's the vector GH? GH is supposed to be the one. I can move it around first. I want GH to be from B1 to C, okay? Maybe I'll relabel it. So where is the point? Okay, let me try to find it. So this is the point. Okay? Maybe I'll rename it first. I call it B1. Anyway, B double prime perhaps. No. No, I cannot use this symbol. Then maybe I try another. I just want to find a better point to describe it. Never mind, I just call it B3 for it, maybe. Okay, so that okay, now we define the vector. I can see this one. U, the vector U can be now B3 to the point C. Okay, so I will define it. And similarly, I want the other vectors to be from A pi, this one. I try to rewrite it to make it easier to type. A3 to what? To this C pi. Right? C pi is fine, I can just write A3 to C pi. Alright, so I can redefine it. So that means if I drag the original point, the pattern still stick together, right? Entire. And when I drag it, it still stick together. So this is what you see in the previous part, something like similar, right? Similar to the previous part. Right? Now finally, if I want to continue more quickly in covering the whole plane, then you can use further commands. Okay? So that is the command. Can you see it? Maybe I try this way. I have to do it sequentially, okay? Repeatedly, or maybe I say that. So I can use the sequence command. Sequence here, you can do something repeatedly, okay? With some indicator there. So I do the translation, but repeatedly, not just once, several times. Translate the object tile, and I make it multiples of u, the vector u. Okay, so I can put k times u, and then define the k. Okay, k is something from -3 to 3. You see this? Okay, so that is a new set, L1. L1 is this active set. Okay? So if I close the other, then you can see more clearly. Right? Or even the original one. Okay? And you can see this for the pentagons. How about pentagon? And you switch off all these. Is it clear? Mm-hmm. Or I can switch off all the points. So let's switch off all the points. Yes, I can select all and then hide all the points. Okay. All right, I just continue. Remember, this list, this is another set, L1. All right? It is the result of translating all this together. So I further make some translation of the whole row. Sequence, okay, L1, translate. is L1. Okay. I make it, I think, just K times V. This time, I move it in another direction, K times V. Well, K is also negative 3 to 3. Okay, then you see the entire set. Actually, you can combine the two sequences combined into one, if you like. Okay, that is the multiples of U plus multiples of V. Right? You can make it just one entire combine then. But of course, you can practice later, right? Whether you want to shorten it or maybe combine it together. So that is one way to do the tessellation. Right? So that is one way to do the tessellation. Right? If I open the point again, then you can continue to modify it. The whole pattern is still the same. Okay? So this is what I like to try to demonstrate how we use the geometry tools, right, for construction. You need I need more time to get used to the tools and the skill, because it's not simply, actually it's not simply just a list of commands, right? It's also required you some thinking about the geometry environment as well, right? And how to think, and also including transformation and vectors, right? So vectors will be included in the IDE curriculum in some way, right? So it can be something that you can practice a little bit more, right? Or try to explore how it works. Okay? And by the way, this one is done in a different ways. Okay, it's not exactly the same. The previous one I showed you, I don't know whether I have any links here. Yeah, this one. Okay, so I give you a little bit more information about the constructions of this one. Right? Actually, later on, I find an even simpler way to create it. Right? So the one I just showed you is more intuitive. I mean, stick to the observation that we made, right, about the transformation, right? But actually, if you deconstruct it in another manner, then you will observe another interesting way of making this pattern. I don't know whether I have the two views or not. No. All right, so I can let you read it later if you like. Okay? You'll see whether you understand the shortcut or some other way of rearranging the patterns. All right, so we finish here. All right. Okay. So anything you want to ask, first of all?